this is a real life example for the concept of pointers. So I hope you all have seen this. This is just a visiting card. So what is the purpose of a visiting card? It is used to direct you to some official address, right? So when you are having a visiting card of a person, you have that person's designation, his contact number and his official address. So if you want to meet him in person, you can use the address in this visiting card to go meet that particular person. So a visiting card is said to store the address and necessary information of a person, right? Similarly, pointers are those variables which stores the address of another variable. Is that clear? Pointers are those variables which stores the address of another variable. Let's see that. So here, as I said, variables, they are variables used to store the address of another variable, and it can be of any type. If you are going to store the address of an integer variable, then the pointer can be an integer pointer. Similarly, if you are storing the address of another pointer using a second pointer, in that case, the type of the pointer should be a pointer itself. Okay, so we'll see programming examples for all these. Then, pointer is something which is available in C programming, C++ programming, but it is not available in Java programming. This is because pointer is a concept which is going to make a dependency to the underlying operating system features. So, based on the underlying architecture, the pointer may have a size variation. So, generally it has got 2 bytes of size for a 32-bit architecture. But what happens is that Java is a platform independent language. So this pointer feature is a platform dependent language. That is why it is removed in Java programming. But it is available in C and C++. So this is an example. There is a variable q, an integer variable q, which stores the value 200. So as you can see, since this particular memory is each of 1 byte, integer is taken normally either a 2 byte or a 4 byte. So here I am taking just a 2 byte. Okay, so for storing one single integer, you have to use 2 memory locations, right? So q is pointing to this 2 bytes of memory. And what will be the address assigned to q? It will be the starting address. So when a pointer p is storing the address of q, it will be storing the starting address of that particular variable. Okay, so here you can see this is q, this is the content of q, this is p, it is assigned at some other memory location and it is storing the address of q. This is how pointer works. So declaring pointers. Now to the programming part of it. So here you can see there is a variable, integer variable p, which is having a value 10, and this is your pointer variable. So here you can see int space star q is equal to ampersand p. This is how you declare. You can either write it as int space asterisk symbol q, or you can write it as int asterisk symbol space q. Both are used. Okay, so this is declaring that this is a pointer variable and this is the address of p. Ampersand refers to the address assigned to the variable p. Okay, you can even split this into two. If you don't know what is the address to be assigned to q, in that case you can split it into 2 parts and you can first declare the variable and at a later point of time you can initialize the value to the address of p. This is also possible. Okay, is that clear? Now, the asterisk symbol used along with pointers, it is called indirection pointer, or it is used to dereference a pointer. What do you mean by dereferencing? Dereferencing is that you are trying to fetch the actual data which is stored in the address that is stored as a value in the pointer variable's address location. Clear? You are trying to fetch the data which is stored inside the address location that is being the content of the pointer variable. Okay, that is called the pointer. So this is a sample program. Okay, so this is just the basic program that is going to let you know how a pointer works. Okay, so here you have a variable a with an initial value 10, which means a is assigned an address, and at that address location you are storing the value 10. Then there you are declaring a variable p. Okay, so here I am using the second approach, int asterisk symbol space p. Okay, then what happens? P is equal to ampersand a, which means p is storing the address of variable a. Okay, then there are a set of print statements here. First statement is you are directly printing the address of a. Okay, this is just to let you know that the content of address of a and the content being stored in p are both the same. So address of a, what is percentage u type specifier specifying? It is an unsigned integer. This is normally used when we are referring to a address. Okay, so address of a is equal to percentage u, and what is the input data? It is ampersand a, which is the normal address of a. Okay, value of a, this is the normal printf statement that we use because it is an integer. The type specifier is percentage d, and what is it? You are directly passing the value of a. Okay, then again address of p, this refers to the memory location which is assigned to the variable p. Okay, what happens? It is again percentage u. This is referring to the address of p, so this is given as ampersand p. Then value of p, what is value of p? That value which is stored inside the memory which is assigned for p, right? So it is again an address, that is why the type specifier is set as percentage u, and what is the content? It is p itself, directly passing the content. Then value of asterisk p or star p. So this is dereferencing. Here you are taking the type specifier as percentage d. Why is that so? This is because you are dereferencing, which means you are going into the original memory location which was the content of p and fetching what was residing there. Clear? You are going to the memory location which is stored inside the content of p, and you are fetching what is the real integer value which is stored inside p. Okay, so that is done by dereferencing, and see this is dereferencing. Clear? So this is the preferred output. Here you can see address of a is this one, value of a is this one, and all of this. So here you can see value of p and address of a are exactly the same. Value of a and value of star p is exactly the same. Address of p is another value, another memory address. So I hope things are clear now. Next, this is about null pointer. Just like you initialize some integers with 0 or an initial value, if you want a pointer to be initialized to something which is not existing at that moment, then you can use the null pointer. Okay, so what happens? You don't know what is the real value to be assigned, so you are just declaring the pointer variable and you are assigning it with an initial value called null. So this is how you make the declaration happen. Int asterisk p is equal to null, which means that there is a pointer and it is right now having no value, that is null. Okay, so this is used for avoiding confusions or any garbage values to enter over all that. Okay, so next is how to use pointers along with arrays. So here what happens? You can see a program where an array is initialized already. It is declared and initialized with values already. Okay, so there is an array A, and what happens? You are creating a pointer with a value which is the address of the first element of A. See, address of first element of A. Clear? Okay, then what happens? You are initializing a loop, and what happens? You are going to display the content of the array using pointer. You are going to display the content of array using pointer. Rather, we have been familiar with doing the same with A of I. But rather than A of I, here you are going to use something which is related to B. Okay. So since it is the content, you have to use the dereferencing variable. okay, which is the asterisk symbol. So here you can see array of percentage D, that is array of 0 to 5, 0 to 4 is, okay, percentage D, which is the actual content. Okay, so first one is I and the next one C, asterisk of P plus I. What was the initial value of P? It was the base address. Then whatever being the iterative variable, you will be iterating it accordingly. Okay. Then if you want to print the address of those elements, then we have to use it this way. Okay. So 5 is stored at this particular memory location. That is what expected from this printf statement. So that is why the second type specifier is %u, which refers to an address. Okay, so this is the output. The first for loop will generate these many outputs. Okay, so array 0 is 5 to array 4 is 9. Okay, next you have to say where is 5 located, where is 4 located, and so on. That is done by the second printf statement. See, 5 is at this particular memory location, 4 is at this particular memory location. So here an integer is of 4 bytes. That is why you can see a 4-byte difference in all these addresses. Okay, so the first one is at 8. Then after 4 bytes, you have the next element being stored, which is 4. That is at 12, and so on. So I hope things are clear now. Pass by reference. So when we have discussed about passing arguments into functions, there are two types. We have told that there are two types. One is pass by value, where you are passing a copy of the value which is allocated to a particular variable. Right? That is pass by value, which you would have probably done lots of examples of. Now, what is pass by reference? Instead of the value, you are passing the address of your argument. Right? That is passed by reference. So what happens, or what is pointer doing here? Here what happens is, you are passing the address of your actual argument. But when the formal method or the formal arguments are considered, there we use pointers to receive those arguments. Okay, you are sending the address as argument. There should be someone to receive those arguments, and that is done by using pointers. We'll see programming examples for that. Okay, so since it is the original address of your arguments being passed, whatever be the changes that happens in the formal arguments will be reflected definitely inside the actual argument. Is that clear? Now let's see an example. So here you are going to swap the contents of two variables x and y, and that will be done using pass by reference method. Okay, so let's see how this is done. So here there is a method called void swap. See here, this is the method definition. What is that method declaration part? You have two pointer arguments. Okay, the formal arguments are of type pointers, integer pointers, which means they are accepting the address of integer variables. Okay, then what happens? Here you have two variables x and y, and you are reading the value and you are displaying the values before swapping. Then you are calling the swap method. How was it being called? You are passing the address of x and y. Okay, so what happens? Let's switch to the swap method. Okay, so what happens in the swap method? To receive the address of x, there is an integer pointer a. To receive the address of y, there is an integer pointer b. Now a is having the address of x and b is having the address of y. This is the actual argument, this is the formal argument. Okay, now what happens? You are just changing the contents of a and b. What was the content of a? It was the address of x. And what was the content of b? It was the address of y. Now you are going to change it as a will contain the address of y and b will contain the address of x. What happened in real? It was that those memory locations assigned for x and y were swapped, which means the contents were also swapped. Now x is pointing to that memory location where you had the address initially as y, and y is pointing to that location where you had the initial address as x. Okay, this is what I said before. Whatever changes that happens for the formal argument will be reflected inside the actual argument. Okay, So here you can see there is no return at all. Still you can see that the swapping has been done. So this that particular program. See, before the swapping, x was having the value 10 and y was having the value 5. After swapping, what happens? X is having the value 5 and y is having the value 10. This is just because not these values were swapped, rather x and y got swapped. That is pass by reference swapping method. Clear? You are not changing the value 5 and x. It is there itself. But you are changing x and y. That is pass by reference swapping. Clear? Now of this particular topic, pointer to an array versus array of pointers. So, what do you mean by pointer to an array? It is a pointer which is pointing to the array, right? It is a pointer which is pointing to the array, or it is a pointer which stores the starting address of an array. It is a pointer which stores the starting address of an array. This we have already seen in our previous examples. You have an array here and you are initializing the pointer, integer pointer to have the initial address, the base address of A. That is exactly the same thing. This is pointer to an array. Now what is array of pointers? It is just an array which stores all its elements as pointer values. Okay. You can even say it is an array which stores addresses. Okay. So how to declare an array of pointers? So here you can see a syntax. Int asterisk variable name with array size. What happens here? Int asterisk. This is the variable name and size is 3. So this is an array which stores 3 memory addresses. Okay. This is an array which stores 3 memory addresses. So this is how it is done. This is an integer address storing array. Okay. Clear? So that's all for today. If you have any queries, you can update me. Thank you.